Now in this chapter we'll start looking at the impacts of jets, and the very first topic we'll look at is the force exerted by a jet on a flat vertical plate. So this is a flat vertical plate, okay, on which a jet of a liquid, let us say water, is impinging in a horizontal direction like this. So this is the pipe and this is the nozzle which is directing the stream of water onto this flat plate which is in the vertical direction. Now what happens is the stream of, or the jet of water, is coming with a velocity of v. After it strikes the plate, it deflects by 90 degrees. So if the jet of water is moving along in this direction initially, after striking the plate it gets deflected by 90 degrees like this. So there is a change in the velocity, means there is a change in the direction of the velocity and also the magnitude, because initially you have value v and the final would be 0 because this plate is not moving anywhere. So the water after striking it will just fall down. Okay, so the magnitude and the direction of the velocity both are changing, means there will be a change in the momentum of the liquid. So in this chapter we will be applying the force or the impulse momentum equation. Okay, impulse momentum equation says that the force exerted in a particular direction is the rate of change of momentum in that direction. Okay, so if I find out the force in the x direction, so force exerted by the jet onto the plate in the x direction would be initial momentum minus the final momentum divided by dt. Now what is the initial momentum? It is the mass flow rate into the velocity. So I'll just write down mass, okay, flow rate. So the mass can be taken out and then you have this dt over here. Initial momentum is what? It is equal to the initial velocity, that is v, because mass into velocity is momentum. I have taken out mass. This would be 0 because the final velocity is 0. So your mass upon time gives you the mass flow rate. So this would become m dot into v. What is m dot? M dot is the mass flow rate, so which is equal to density into volume per second. Volume per second is area into velocity. So this is what you get. So the force exerted is rho av square, where a is the area of the jet and the diameter of this jet is small d. So area would be pi upon 4 d square. So this is the expression to remember for this particular case. After the vertical plate, let's move on to the next video and talk about a flat inclined plate.